Hi, so if you thought the explanations on some of the previous videos I did were bad, wait till you get to this one. So I'm going to be explaining again a lot less since my main technician is on vacation, meaning I have to work a lot faster, which means I don't have time to show you everything and explain everything, since these boards got to get in and they got to go out. So this has no green light on the charger, right? Now, as I have said in previous videos, in order to have a green light on the charger, you need the one-wire circuit to be working. The one-wire circuit on these machines requires that PP3V42_G3 hot be present. So what I do is I'm going to measure here to see if I have voltage on PP3V42. I do not have anything on PP3V42. So what I'm going to do now is check to see if there is a short to ground on the bus by putting my multimeter here into diode mode, putting red probe on ground, and then red probe on each side of the inductor for PP3V42. Now what I notice here is that there is no short to ground. So what I'm going to do now is see if there's actual power going in to the chip that supplies this. So let's take a look at how that works. So very, very quickly here, because again I said I am going to be keeping my explanation short because I do have to get on with this. I cannot explain everything when I am the only person doing all this shit, because then people are going to start going, "Where's my stuff not fixed yet? Why I sent this to you yesterday and it still ain't done yet?" Blah, 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 blah. So over here, this is the 3.42 volt power supply. So we don't have any power over here. There is no short on either side of that. So let's see if power is going into it. Let's see if the charger power is going in over here. Now again, I'm not going to show you me looking for it on the board view. I already know where this crap is because I've been doing this for a long fucking time. So I am just going to go back to my multimeter view. I'm going to make that back to full screen. We're going to see if power is there. We change this back to voltage mode. And let's see. So is power going into the chip? It sure is. It sure was until I stopped touching that properly, wasn't it? So it is, right? That's good. Now let's go over here. Let's try where this diode is. So power is going through there. Let's see if it's on the other side over here. Measuring on the diode. Oh, of course, let's go back to full screening it. Come on, mofo. Okay. And power is there. Okay, so now we're going to go and look at something else. So we're going to see if we have power on this resistor, R6995, going here. Now there's a ton pin. Now, I'm not going to go through Googling it and how to find it out because I've shown you how to use Google at least 3 damn times in these videos. But what I'm going to say over here is that the ton pin usually sets switching frequency for a switching power supply. The way this power supply works, and again, if you want to see how a switching power supply works, look at any of the videos I've done on buck converters. Look at the video I did for a MacBook Air 3023 CPU V-Core. I've explained it a million times already. But the buck converter or any type of that some kind of switching power supply like that works based on switching a higher power to create a lower power, or switching a lower power to ground through an inductor to make it into a higher power. It mainly works on switching. Now, this power supply, as you can see over here, has 2 different inputs. It has an input for PP-G3 hot, which is a 12.6 volt power supply, and it also has an input for PP18V5, which is an 18.5 volt power supply. Now this is always going to be making 3.465 volts as its output. It says right over here, V out 3.465. This power line is always going to be that much, but it has 2 different inputs. So how is this chip going to manage? Well, the way it does it is by having this little ton pin. I have no idea why ton means that, but I know it because I've Googled enough data sheets, and that's what this pin usually does. What it does is it references the power over here to set the switching frequency. So if we have an 18 volt input, we're going to have a slower switching rate to get to 3.4 than if we had 12 volts. Because again, to make 12 into 3, you're going to need more pulses than you would need to make 18 into 3. So let's see if this shit works. So we're going to go and measure on the other side of the board where R6995 is. And again, I am not going to show, usually I go through, where is this component? And I'm not doing that this time around because I've shown you how to use the board view software. You know how to use the board view software. I don't feel like wasting time showing you it. And again, these components are components that I check so often on these A1278 boards that it's ingrained in my head. I know exactly what they are. As you can see here, instead of having 16 volts on that resistor, I have almost nothing, which means that the internal board via is probably blown and destroyed. So this is where I'm going to reference the board view to see which one of those is pin 1. I want to see which one is pin 1 because that is where I'm going to be going to run my wire. So let's see. So pin 1 over here, it's going to be on the left. So what I'm going to do here, first thing I'm going to do is measure that resistor to ensure that it is the 1 million ohms that the schematic tells me that it should be. So we're going to go back to resistance mode on the multimeter. We're going to measure that resistor to see if it is actually functioning and good and works. And it's good, it works. So now what I'm going to do is I'm going to run a wire from the diode. So what I'm going to do, where the voltage breaks off, just to show you, is right over here. So between pin 3 of this diode and pin 1 of this resistor. So this and this is no good. So let's see where pin 3, that pin 3 of that diode I believe is the bottom one, pretty sure. So what I'm going to do now is I'm going to take a wire that I took from a MacBook Pro battery right here. I'm going to trim it and I'm going to solder it on and see where I go from there. This board looked like a complete nightmare when I got it, so I have no expectations of that being the only thing wrong with it. I fully expect to have to do a lot more extra additional bullshit to make this work, but this is here a nice start. So let's get started. I'm going to tin my wire on both sides and get ready to get this thing out of here. I shouldn't really even be working on this. This is one of those things where like person dropped it off 2 hours ago. Person actually called an hour ago like, why ain't this done yet? It's like, motherfucker, this is motherboard repair. Why the fuck isn't it done yet? Why don't you do it your damn self? I wish you the best of luck finding somebody else to do this in that time frame. Really, honestly, good luck. Good fucking luck. But is what it is what it is. This is... Wouldn't it help if I actually showed you what I was doing on the screen? That would help a little bit, I think. Just with the whole understanding of the process. Okay. Some nasty, disgusting flux. Added way too much there for a second. Now I'm damn sure that those 2 points are actually meant to be touching, but because I don't 100% remember, I'm going to measure, because if they are, I'm not going to bother cleaning it perfectly. And they are actually meant to be touching, which is totally fine that I couldn't join them in that manner. So now it's time to stick my wire in there. Let's get the wire in there. Ugh. You know, I should have put that on the other way. Always thinking of the right thing to do after I already did the wrong thing. That is me. What I said about not heating solder without adding new solder or new flux. It is important, you know. So we take this, go right here. I hope that my hand will stay straight for even a quarter of a fucking second so that I can solder that. Who am I kidding? And yes, who am I kidding indeed? Okay. Take this. We run you around here. Little wire is going around the world. It's taking a nice trip. Making a nice... Before it stops at its destination. I notice that I have moved myself off. Here we go. Okay. Ten the other ends of the wire. Tin the ends of the resistor. Where are you? You're hiding behind blur. Okay, that looks good. Who am I kidding? That looks disgusting, but I mean good in terms that it will work. I should never call something that's covered in poisonous flux and disgusting, nasty shit good. That is really kind of pushing it. That doesn't look good. That looks like it causes cancer, but it looks good for the purposes that it will work and allow me to have a functioning motherboard. Okay, now again, remember, you want to put the wire as close to the board as possible, so that is absolutely unacceptable. So that it creates the least amount of tension. Alrighty. And even when you're done with all that, like literally be pushing this thing to the board and then, you know, have it soldered on there. That you know for a fact that... Okay, so that is terrible. That was actually god-awful humiliating. So let's try that again. We're gonna... Alrighty. So that is tinned. I'm gonna take my wire, which did a really bad job of tinning just a second ago. Cut that. We are going to splice it again, strip it again. Tin it again. Flux it again. I can't wait to get my nice HAKKO tweezers back. This is some Vetus shit. I have no idea how Vetus tweezers made it into my store, but they suck. Like my HAKKO tweezers, they're bent for good reason because they've been banged and beaten, and these are bent from just like grabbing wire. I ordered a bunch today. Best $5.17 you will ever spend on tweezers, let me tell you that much. Okay, so remember what that wire pushed. I can drag the board across the table by the wire. Alrighty. Let's see what happens when I plug this in. Does it go on fire? Doesn't go on fire, but also still lacking in the green light department. So we're going to go back and continue measuring and see what's going on. So, alrighty, we are still in resistance mode. We changed that to voltage mode. I can bend this a little so we can both see it without me having to look at the screen all the time. So, at that point that I just ran that wire to, there is 16. On the other end is... Remember, that resistor actually did measure the ohmage that it's supposed to, right? And it does go into my U6990. So that is supposed to go on a which pin of U6990? I should actually measure and make sure there's continuity there. Let's see. Okay, so of my U6990, that goes into pin number 3. Pin number 3 of U6990. Pin 3 is going to be over there. What if the U6990 is bad? What if it saw a surge? I mean, I think that resistor saw a surge on one part, and it saw a surge from the highest voltage line of the computer, so it is reasonable to expect that maybe there's something wrong. Maybe I should replace that resistor even though it looks nice. What have I got to lose? 8 cents? It's probably fine. There's a 99% chance that there's zero wrong with that resistor. But before I drive myself nuts, before I run I might as well just humor myself. Before we go on doing that, though, what I'd like to do is I'd like to actually see that there's continuity between that resistor and the other side of the board. So we're going to put the multimeter in a mode where it's going to make a loud beeping noise when the two probes have continuity. So when these two touch, the multimeter will beep, which you're never going to hear because I have the air filter and the air conditioner and the other air filter and the hot air station and the noise reduction thingy that helps so that you don't hear all that crap. This is the part that sucks. This really sucks. This is the least fun game that there is in board repair. Okay, so that's good. So what I can assume now is that maybe there's a problem with U6990. Because now, before it wasn't getting any power on the ton rail. Now it is getting power there, it's just not doing anything with it. So I can reasonably blame it. Remember, when you're doing any soldering on the bottom, the BGA RAM slot is the bottom slot, so you should not have memory in it, because if you do, it's very easy for it to break and fall off. So be careful with this, because you're doing soldering near a RAM slot that's soldered in a really shitty way. And my wire just flew off because it's right next to the thing that I need to replace. And the thing I need to replace is stuck to the board, which gives me a good which makes me believe that it's probably messed. Probably fakakta in some way. And the board I want to take it from has had that stolen already. Lovely. This board has not had it stolen already. Good, good. Okay, we're going to steal the PP3V42 chip from here. I have the heat turned down, but it's still a pain in the ass to not burn the RAM slot when working in the microscope. Working outside the RAM slot, it's possible, but working outside the microscope, it is possible. Working in the microscope, you have to work at this ridiculous angle on this. So that makes it a little difficult. These tweezers that I have are so bad, I'm actually just trying to use my hand to do this. They're really awful. Vetus tweezers, wherever the hell these came from. This is the L2 computer of tweezers. Like, okay, PP3V42. Show me PP3V42. Okay, for curiosity's sake, let's replace this resistor. My stupid TV wants to power off, even though there's a signal going to it unless I touch something on the remote. It's because I don't have a monitor, I have a Seiki. A cheap-ass Seiki. Making this neat can be accomplished later. Making this work. Let's see, progress. So, even though that resistor measured a perfect 1 million ohms, even though the resistor said that it worked, that piece of shit did not. What? Don't ask me. Don't fucking ask me why. See, now on the other side of that resistor, I have a voltage that's more what I was expecting. PP3V42 is... It was present for a second, and then it went away. What the... Here we go. That was because I kicked the charger with my foot there for a second. See that? Now PP bus G3 hot is where it's supposed to be, and oh dear God, something is burning. Okay, let's see. Something just burned me. What just burned me? Let's see. The red spot is over here. I was touching the board like this. I have a hole in my hand over here, which points to... this steaming pile of shit with a bunch of red next to it. Could you have burned me? Oh, hells yeah, you burned me. Okay. So, next fucking problem to get to. Let's see, what is burning me here? Let's see, does this actually spin a fan? That would be something to see right now. See if we've made any progress. Do you turn on? Or are you still dead? Green light, no fan spin. Okay. Something here is burning. But what? Now, who here remembers my video on how to find a short without a $6,300 camera? Does anybody remember the video on how to find a short without a $6,300 camera? I'm going to show you how we do it. let me just get my tools. Now, as you all know, I firmly believe that using your brain is far better a solution than spending money. So, what we're going to do here is put some 99% alcohol on the board, and let's see where it disappears from first. I really should get my... I have these little syringes with these fine needles, but I use them all for different types of Kester flux over there, and I don't think I have one left to use here, so I'm just going to pour it from the cap. Eventually, the alcohol is going to evaporate, and wherever it evaporates, that's where the short to ground is, whatever. But it's not evaporating because I want to show you how to do something in a video. So here's the thing. I could try really hard to figure out where the specific short is, or I could just replace all this shit because I buy the dead boards for like 15, 20 bucks and I don't care. So this chip, yeah, you're bad. And just for the hell of it, these caps that look really, really brown over that area before, they are getting tossed off too. So let's get started. I'm not taking out a multimeter. I'm not measuring resistors. I'm not measuring tabs. I'm using common sense. That thing burned me. I know it creates power for a 5-volt line. It has red shit on it. It can GTFO. But yeah, this is one of those things that you really got to think about in terms of brain usage here. I mean, that resistor measured fine. It measured fine. It really did. It measured fine. It wasn't carrying power. That's why, like, knowing what to expect is so important. It's so much more important than just basic measurements, and there's really a common sense aspect that's important here. Like that because I just felt like, you know, if it's just basic common sense, like if 16 volts, that's a very high power, 16, 18 volts, rushed to a point, destroyed the board via, why would it not destroy the little 1 million ohm resistor in front of it? You know, I mean, like logic and common sense just dictated that resistor should be destroyed because, you know, it's like a bulldozer hits you and the bumper of the bulldozer is damaged, but the person is not. Like that makes no sense. You know, the person should be in extreme pain in the hospital. And the same here. Even though the resistor measured a perfect 1 million ohms, it didn't work. So even though it was measuring right with the multimeter, when it was actually tasked at carrying a high voltage, it failed. So we replace it, and all is good. Then, again, did I take out the multimeter there? No, I got burned. I said, the thing that burned me can leave. So, and that's what I'm doing now. I'm going to replace the thing that burned me with another one. Again, this is a very common chip to go bad. That's why I have a spool of it. You know, if you're doing anything regularly for a living and looking to make money at it, you should be prepared. So, you know, I do this regularly. I have spools of chips. You know, if you do iPhone screen repair, you should not have to overnight screens to have them for people. I see all these posts in these dumbass, like, Facebook groups. Well, I used to. I deleted my Facebook out of just fundamental frustration with the human race. But where people were like, these people are impatient. They don't want to wait, this, that, and the other. And it's like, you advertise, you say, like, we fix iPhones. We are the best at fixing iPhones. We do this for the iPhones. And you don't got a screen for a 5S? Like, really? Really? It must be the customer. It must be that impatient customer. That's the problem. Not you for being a cheap fucking idiot that doesn't stock a $35 part. No, it's them. It's all them. It's all them. And that's the thing. Like, you can either choose to sit there and bitch about it, or you can choose to set up your business in a manner where you can make money at it. I know which one I'm going to choose. Yeah, needless to say, there's a reason that Jessa is going to be teaching the soldering portion of the motherboard repair school that we're doing, and I am going to be doing how to use your brain, diagnostics, troubleshooting, because I suck at soldering. Oh, this is such a 2-year-old job that I'm doing. Such a 2-year-old's job. Okay. Just in case any of you were the ones that also burned me, you can GTFO. This cap can GTFO. I think a bent tip is really good if you suck like I do at soldering, even after 17 years of it, because it lets you get under things. You see what I did there? So I saw that this pin wasn't really connected the way I wanted it to be. So what I did was I put the, I can actually touch it, and I can feel the ridge, so I can feel the feedback in my wrist, so I know that I actually got in there and I touched it with the solder, which is cool. At least cool to me. Probably you don't give a fuck, but I'm silly with what I find interesting and entertaining. These boards that I'm stealing this stuff from look pretty well baked. Let's see, what is that stuff? You actually can't see the terrible mistake I made because my office and the Poland Spring bottle is in the way. I may just keep it like that. Okay, so those 2 points that are touching, those are, yeah, they can't touch. Yeah, they can't touch. No fucking way. Okay, so get rid of that. And short gone. Does the fan spin? Now here, if the fan spins, we're still not done. I mean, don't get me wrong, that'll mean that we made some progress. But we still have other things to do. Because this also has corrosion by the CPU IMVP ton pins. What are you doing with Sharky? Give him back! You stole Sharky. What are you doing, Sharky? Okay, now the fan spins and it turns on. Now again, 99% of the time I would say that this is done. But here we can't. Because there's other bullshit to be done. See over here? Show you under the multimeter. And show you under the microscope, not a multimeter. So, this resistor over here, and this resistor over here, these two look like complete shit. Let's measure the resistance. See what we get. Remember, when measuring resistance of a single resistor, it doesn't matter which ends of the resistor you put the probe point. You can put it on either one. Okay. You know what? I don't even give a shit that these are measuring what they're supposed to. I don't trust them. They're getting swapped. So, what do I mean by this? So remember what I said about the ton pin being for setting switching frequency? Let me show you more of that. Okay, you're probably confused to hell at this point. What do I mean with these two resistors? And again, I'm going to keep this very, very short because, as I said, I have boards to fix. I have a big pile over here. I do not have time for this because when I'm done with all these boards, I got to fix all the regular laptops too. Until the tech is back from knee surgery. So this is a control chip that controls the buck regulator, buck converter, buck horse, whatever, for CPU V-core over here. Now this chip can work in many different laptops. It can work on laptops that run off of 5 volts, laptops that run off of 8 volts, off of laptops that run off of 12 volts. Obviously, in order to know what the switching frequency should be, it needs to know what the input power supply is. So this can actually adapt. It can set the switching frequency differently to output the same power based on the input power supply. So let's say I have 5 slices of 12 volts, right? I'm going to have more power with 5 slices of 12 volts than I would with 5 slices of 8 volts. So if I were running off of an 8 volt power supply, I may need 8 or 9 slices of it to get 1 volt for CPU V-core, versus with a 12 volt power supply, since it's a larger input power, I may only need 3 or 5 volt slices to get to 1 volt of CPU V-core. So what this does is it measures the input power in order to set the switching frequency. Again, if you want to see what switching frequency is, search for 820-3023 CPU V-core video. I show you how a buck converter works. I show you it on the oscilloscope. You can actually see the pulses, you can see the spikes, and you can get a general visual representation of what's going on. Not going to do that here because this is a practical video and I just want to get it done. I don't. Okay. I don't like knowing that I have 15 or 20 or whatever things to get to. It's an annoying feeling. So let's get through. And admit it, it may sound like an excuse to you, but it is the truth that doing videos does slow the process down. Like this would be done already if I wasn't explaining, if I wasn't switching back and forth the camera here. And also speaking. Speaking in general just slows down my workflow. Without all of that, this gets done a lot faster. But I do like having the opportunity to show you how to do this. And the only way to really keep this interesting is to do them, now. It's not like if I finish this and I say, this is what you should look for, and this is what you should do, it's boring. When you do it in real time, it's kind of interesting because you get to see the thought process in real time. And you also get to see the things that make me look like an idiot in real time. Because that's the thing that nobody understands. Like, nobody respects how hard it is to do this type of work. They really fucking don't. Especially, again, like you saw, the resistor measured properly. It looked good and measured properly, and it was fucking dead. Like, it's hard enough to find out on these boards what components work and what don't. That is hard enough. That's enough education and enough time, enough nightmare, enough misery. But then when they actually work, when they show that they work and they don't, that is bullshit. Like, and this is why doing these in real time is so important to me. So what I have here, this is for high side current sensing. I'm not even, or voltage sense for PP bus G3 hot. I'm honestly not even going to show you it on the schematic because I just got to get this done. But I'm not going to measure it. I just know that this computer is going to fail sensor tests and run slow as shit because that looks like shit. So let's just replace that before this becomes a nightmare. This area of the board is also where most of the SMC sensor crap goes. So let's just take a quick visual inspection here and see if any of the vias are corroded or blown. None of them appear to be. So I'm going to just replace that and call it a day. Oh, but I've stolen it from everything already. Yeah, big surprise there. Okay, oh my god, I forgot to steal it from this one. I must have forgot that this board was here. I never forget to steal important stuff like that. Okay. And as usual, don't heat the BIOS chip. Try to avoid heating the BIOS chip while doing this. Many of them are pieces of shit. And BIOS programming on these things sucks. Like, there are all these places where they say, we have a guide on how to do it. We have a guide on how to do it. Just read here. And then you read and it has absolutely nothing to do with your machine, nothing to do with the process. And they like, it's a nightmare. You don't want to learn how to program BIOS issues because you burned your BIOS chip. So just don't burn your BIOS chip. Don't burn it. You'll be good. Okay. Fluxy, fluxy, fluxy. This is a rabbit hole board. This is one of, I try to put these in the bottom of the pile. I don't know why I didn't put this in the bottom of the pile. That's another thing I'm going to be teaching at this course, by the way. Avoiding rabbit hole boards, how to deal with rabbit hole boards, where it's a rabbit hole to hell and you're just going to spend a lot of time on something at the expense of everything else. Because again, it's just one problem after another, after another, after another. Like, it's not I'm replacing that one wire. I'm replacing the wire and the resistor and the that, and the high side current sensing and the, it's just awful. It's one thing after another, after another. It could drive you to drink. Shh. So, let's see if we have the basics working on this pile of shit. Okay, let's take a little bit of this napkin here. Wait a second, why am I using this when I just got alcohol? Oh, yeah, my alcohol bottles came in, thank God. I was tired of using methyl ethyl ketone. You may be wondering why I'm doing this instead of using the dispenser. I don't know if you've seen the earlier videos how often I used to fight with that little dispenser just to get it to do anything. I've tried a lot of those little desk dispensers where you just tap it and the alcohol comes out. And here's what happens. Here's what happens in the real world with all of those that I buy. From the cheap ones off of eBay to the good ones from Allspec. What happens with the little alcohol dispenser, hate wired microphones, is that you tap it and nothing comes out. You tap it again, nothing comes out. You tap it again and you finally go, and you hit it and the alcohol just sprays everywhere and goes in your eye. I was sick and tired of getting alcohol in my eye, and I was sick and tired of getting angry at an alcohol dispenser. So, until I find one that is not a piece of shit, this will do for me. Alrighty. And the CPU heatsink, we're going to use a different part of the paper towel to clean that because I don't want to be just rubbing old thermal paste around with alcohol. And then we use a dry part of the napkin to remove the liquid. You want to have a clean CPU heatsink, especially with Apple products, because Apple products have no cooling. Like, the cooling in almost every Apple product I've ever encountered is just complete garbage. Like, there's no thought towards actual ventilation. So everything that you do to keep the ventilation from working at its best is going to actually harm it. Because again, right out, not even after dust, after years of the fan getting beat up, it's not like you have to wait for the ventilation to become shit. Out of the box, the ventilation on these products is crap. Like, I mean, Apple, they're the only laptops that I know that don't have a vent hole on the bottom. They don't have vent holes by the fan. They have this one little thing in the back with the little slits. It's terrible. It's terrible. It's terrible as not having a wireless microphone. Oh, okay. So let's put this thing back together. So yeah, don't compromise the ventilation on an Apple product. It's already compromised from the moment that you buy it. I also use this Tunic TX4 thermal paste. I was actually enough of a nerd to go to a bunch of different websites and compare review results of different thermal paste a long time ago. I don't trust one specific site, but when every specific site is showing that, like, the worst case scenario is the Tunic is 1 Celsius better than Arctic Silver, and the best case scenario is that it's like 4 or 5 degrees better than the Arctic Silver 5, I'll go with what most of the sites say. And it is important because these machines have really, really bad thermal design. Like, really, really bad thermal design. So everything that I can do on my end to keep it cooler is good. It results in a lower likelihood of somebody coming back and saying, you fixed this a month ago and now it does X, where X is something that is not my fault at all, but they kind of feel like it's my fault because they already paid me, and it still doesn't work again. You always want to try to avoid that. Like, whatever it is you can do within reason to keep people from coming back and saying that something that doesn't work is your fault is something you should do. So if you see all these stupid little problems, you should come up with ways to resolve them before they actually become problems. Unless you just love fighting with people all day. I prefer to make money off of happy customers, so I do what I can to keep this working. Alrighty. Same thing here, like I actually put the adhesive over the speakers again so that they don't jiggle around. So if this thing jiggles, or don't get me wrong, laptop speakers sound like shit. Like there's nothing I can do to not make the speaker sound like crap. It will always sound like complete garbage. But if it sounds like stable garbage, that's better than if it sounds like rattling garbage, because before it broke, it sounded like stable garbage. If it sounds like garbage with a little bit of rattling in the background from it not being stuck on properly, then again, it's one of those things where the person's going to think to themselves, you know, this is not worth going back for. This is not even worth mentioning, but my computer sounded a certain way before, and now it doesn't. And the only thing they're going to think about is that the last time it sounded good was before they brought it to you. And again, it's just all these little things that people do that you don't think about that add up. So use your brain, try to do things right as often as you can, where people are going to notice, where there's going to be an actual difference, a noticeable difference between it being done right and being done like shit. Okay. We stick that on there. And what I'm going to be interested in is seeing how fast this runs off of the battery. Also, I'm going to be interested if this thing even chimes, since there was that crud by the CPU V-core circuit that I showed you. Even though I did replace it, I'm always a little skeptical. The first boot, always a little skeptical. So yeah, there are machines where I see the fan spin and then I end the video because I know that it's going to work. And then there are videos like this where I know that there's a good chance of something else being dead. And because of that, I feel compelled to go through this and show you that the work works. As I said before, if the stuff that I'm doing doesn't work, if I'm incapable, you shouldn't be sending me things. Like the second I prove to you that I am incompetent at my profession, you should stop listening to me. And I don't mean incompetent in terms of making one mistake, because there are a lot of people that like to troll, especially on the internet, where you get to hide behind a computer and hide behind nobody knowing what you do or what you've done or not done in life, and say, oh my God, look at that one thing he got wrong. What an idiot. When I say incompetence, I mean that like repeatedly you prove that you are incapable of producing. So once I show you that about me, if I do show you that about me, I encourage you to stop watching my content and to stop listening to my channel. So I'm always trying to get the point across here. I'm always showing you in the basics that the work that's done actually works. I don't want to watch people who I don't feel are qualified. I don't want to listen to people who I don't feel are qualified. I don't think you should have to listen to people who are unqualified. Battery has no charge. Surprise, surprise. Computer had no one-wire circuit. All right. So I guess showing you that this works quickly off of the battery is going to have to wait for later. CPU V-core is present because it chimes, and you see an apple. I see an orange light on the charger, which indicates that, well, you can't see that because of how damn shiny this room is, how bright this room is, I should say. What I'm thinking of doing is I'm actually thinking, just so that you can see things here better, is putting some diffusers over those lights. I just have to find some good light diffusers. As you can imagine, that is severely low on my list of daily priorities, but it is something I should do if I wanted to this video content and the channel here a little bit more seriously, because this room is terrible for video. So it should boot in a second, and I want to be able to show you that it charges and that the mouse doesn't move around slow on the screen on the battery. But I forgot, this computer uses a hard drive, which means it's going to take forever. I also accidentally unplugged the MagSafe. Great job. This is going to take a while to boot. I hate computers with hard drives. I can't use computers with hard drives. I'm far too spoiled at this point in my life. So it's at 0%, so I'm going to close it for a few minutes, let it charge. After it charges a little bit, I will show you back on the camera that when the mouse moves, that it's not slow. Okay, so let's see if this thing has had any time to charge, if we've gotten anywhere with charging it. So it looks like we're still at only a couple of bars. Let's see how much power that is. That's 12%. So what we're going to be looking for here is that when you move the mouse around, that the mouse cursor can move around fairly quickly. Now I'm going to try to do this without revealing the person's name, because I learned my lesson from doing that, just like I should have learned my lesson on buying a wired microphone. So, alright. And this is to prove that we don't have any issues as a result of that corroded looking transistor. So what I'm doing here is I'm moving the mouse in this out of focus. So what I'm going to do here is I'm going to move the mouse around in this out of focus screen, and you can see that the mouse is moving at a fair rate, which means that we don't have that slowness issue when it's running off of just the battery that you would if that piece was messed up. I'm done. It works. Hope you learned something.